Welcome back to AI.Code.Cast. Today we're diving into a classic coding problem.
Oh, yeah.
Custom string sorting.
You got it.
You have a string, but need to rearrange it based on a specific custom order.
Like shuffling a deck of cards, but the suits have a totally new ranking system.
Exactly.
It's a fun challenge that really tests your algorithm skills.
So imagine you have two strings,
Okay.
order,
Okay.
and A's order is like our rule book.
How good.
It defines that custom sorting order.
Makes sense.
And S is the string that we're actually trying to
Right.
sort according to order.
Okay.
So let's say order is CBA and S is ADCD.
Okay.
How would we rearrange S to match the custom order?
Well, the output would be C-bed
Okay, and why is that?
because we've prioritized characters from S that are in order,
Right.
and we arrange them
Oh.
based on their order in order.
Yeah,
The remaining characters, they can go anywhere.
that makes sense.
Yeah.
This is where it gets interesting. How would we approach this programmatically? What comes to mind first?
Well, the simplest approach
Yeah.
is brute force.
Oh, brute force.
Yeah.
That sounds intense.
It's not as complex as it sounds.
Okay.
We would start by converting eyes
Uh-huh.
into a character array.
Okay.
So that way we can work with individual characters.
Right.
And then we'd compare each character in this array with order
Okay.
to figure out where each character from
Yeah.
fits into that order sequence.
Right.
And then shift them around
Yeah.
until they match the order string.
Got it. So we're
That-
kind of like, almost like bubbling them up in a way.
Exactly.
Right.
But it can be pretty inefficient,
Right.
especially for larger strings.
Yeah.
Imagine doing this with
Huge strings.
yeah, a really long string.
Yeah.
There's got to be a smarter way.
Right. Right.
Right.
I've heard of this thing called frequency counting.
Yeah, frequency counting.
Is that it?
That is a much more efficient strategy.
Okay.
The idea is to tally up how many times each character appears in SES
Okay.
and store this information in like a table or a map.
So we're kind of like taking stock
Yeah, exactly.
of all of our characters first.
Yeah,
Okay.
you got it.
And then what?
So then using these counts,
Yeah.
we can actually build our sorted string piece by piece,
Okay.
making sure that we follow that order
Right.
that was laid out by the order string.
That makes sense.
Yeah.
So what kind of structures are generally used to store these counts?
Hash maps
Okay.
or dictionaries.
Yeah.
They allow us to access the count for each character very quickly.
Right.
But remember, efficiency is key.
Yeah.
The real magic lies in how we actually use that frequency information
Right.
to build our sorted string.
Okay. So we've got our our
Yeah.
frequency map, let's say.
Yeah.
And then,
We know we need to build it efficiently.
yes.
So any hints on how we could do that?
How can we do that?
Yeah.
So I'm thinking we need to minimize the overhead
Right.
of constantly creating new strings
Exactly.
as we add characters.
So what tools can help us with that?
Are we talking about something like a string builder?
You got it.
Okay.
A string builder
Yeah.
avoids the performance hit of creating new string objects every time we add a character.
Okay.
Lets us modify the string in place. It's much faster.
So we've got our frequency map.
Yes.
We've got our string builder.
Okay.
How do we actually use them
All right.
to create that sorted string?
Think about the steps involved.
Okay.
We need to process those characters,
Uh-huh.
add them to the string builder in the right order,
Right.
and make sure we don't add duplicates.
Right.
So how can we use the information from the map and the order string
Yeah.
to do that systematically?
Mm.
What do we need to process first?
The order string.
Yeah.
Character by character.
Right.
And then look it up in our frequency map. If the character is there, we append it to the string builder as many times as its count.
You're on the right track.
Okay.
You got it.
And to avoid adding it again later,
Yes.
we remove it from the frequency map.
You're getting warmer.
Okay.
Think about how we can refine that process
Okay.
to make it more efficient.
Okay.
Do we need to remove it entirely? Or is there a more subtle way
Okay.
to handle its count?
Instead of removing it,
Yeah.
what if we just decrement the count
Exactly.
in the map
You gotta
every time we use it?
decrement the count each time we use it.
Yeah.
That way we only remove it when its count reaches 0.
Right. Okay.
It's like checking items off a list
Yeah.
as we use them.
Okay.
So we've accounted for all the characters in order.
Yeah.
What about those characters from orders that are not present in order?
Oh, right.
What do we do with those?
We just append them
Exactly.
Really?
Just append them to the string builder.
All right.
Since their order isn't specified, we can add them in any sequence.
Okay, so this sounds much more efficient than brute force.
Oh, absolutely.
How much faster is it?
It's a significant improvement.
Okay.
So instead of that O of n times m,
Okay.
where n is the length of s
Right.
and m is the length of order,
Right.
we're looking at a time complexity of O of n plus m
Wow.
with the frequency counting approach.
That's a big difference.
Yeah, big improvement.
Okay, cool.
Yeah.
Are there any, potential pitfalls with this approach?
One thing to consider
Yeah.
is the space complexity.
Oh, right.
We are using extra space
Yeah.
to store that frequency map,
Okay.
which could be a factor if memory is a concern.
Yeah. True.
But in most cases,
yeah.
the space overhead of the map is manageable,
Right.
especially when compared to the performance gains.
Okay, that makes sense.
Yeah.
Are there any other ways to solve this problem
Absolutely.
without even using a frequency map?
There are some solutions that take inspiration from Radix sort,
Oh, interesting.
which is a sorting algorithm
Uh-huh.
typically used for integers.
Okay.
And it works by processing
Yeah.
individual digits of the numbers or ranks.
Radix sort for strings.
Yeah.
How does that work?
It's not a direct implementation of Radix sort,
Okay.
but it's using that core idea
Right.
of sorting based on ranks.
Okay.
So instead of comparing characters directly,
Yeah.
we can assign them a priority level
Okay.
based on their position in order.
So if it's closer to the beginning,
Exactly.
it has a higher priority.
Higher priority
Got it.
comes earlier in the sorted string.
Okay.
Yeah.
How do we determine those ranks, though?
We can pre-compute a lookup table
Okay.
that stores the index
Got it.
of each character in order.
Gotcha.
And that acts as our ranking system,
Okay.
telling us the priority of each character from Hilton.
So a character at index 2 in order would have a rank of 2.
Exactly. And any characters not in order get a lower rank.
Got it.
So they come later in the sorting.
Okay, so we're still using a sorting algorithm,
Right.
but we're making it smarter
Yes.
by giving it this,
We're feeding it
Yeah.
custom ranking information
Yeah.
derived from order.
okay, this is pretty clever.
Yeah. It's about adapting existing tools
Yeah,
to meet our needs.
that makes sense.
Yeah.
Is it as efficient as the frequency counting?
Performance-wise, they are comparable.
Okay.
Both typically have a time complexity of O of n, log n,
Okay.
due to the sorting algorithm used. However,
Yeah.
the frequency counting method might have an edge in terms of memory management
Okay.
for larger strings.
So there's no clear winner.
It depends.
It depends on the situation.
Exactly.
Well-
It's about choosing the right tool for the job.
Now, before we move on,
Yeah.
I'm curious if there are any Python-specific solutions
Oh, yeah.
that kind of stand out.
Python offers some very elegant solutions. Using built-in tools like the counter object
Okay.
and list comprehensions.
The counter object, is that basically a dictionary?
That's right.
That counts how many times
Yeah.
each element appears.
Yeah, we can feed it our strings, and it'll give us that dictionary-like object
Okay.
with characters as keys
Right.
and their counts as values.
Perfect for frequency count.
Yeah, exactly.
So we get our frequency counts from counting.
Yeah. Yes.
Where do list comprehensions come in?
List comprehensions allow us to actually build that sorted string
Right.
in a very compact and readable way.
Okay.
We can leverage those counts from counter
Yeah.
to make sure we add the right number of each character in the right order.
So we're still prioritizing based on order.
Exactly.
Yeah.
For each character in order, we check if it's in our counter and has a round greater than 0.
Right.
If it does,
Yeah.
we append it to our output string that many times.
Do we have to remove it from the counter
No, not necessarily.
after we use it?
List comprehensions in Python
Okay.
handle that repetition based on the count.
Okay.
We don't have to manually manage it.
What about the characters that aren't in order?
Another list comprehension can handle that.
Okay.
We simply iterate through that counter
Right.
and append any characters with a count greater than 0 to our output.
Okay. So it's almost like a two-step process.
Precisely.
The order characters and then whatever's left over.
First, handling the characters from order,
Yeah.
and then sweeping up the remaining characters
Okay.
using the counter.
And because list comprehensions are so optimized in Python,
Exactly.
this is still super efficient.
Incredibly efficient.
Okay.
Yeah.
Python was made for this.
It feels that way.
Okay.
It really highlights the power of
Yeah.
well-designed language features
It does.
and how they can simplify complex tasks.
Okay, so we've seen 3 different approaches.
Yeah.
Brute force, frequency counting,
Radix sort.
Radix sort, yeah.
And then the Python solution.
And then that elegant Python solution.
Yeah, with the counter and list comprehensions.
Each one has their pros and cons.
Absolutely.
Choosing the best one.
Depends on the situation.
Depends on a lot of different things.
The size of the input.
The language.
The programming language.
Yeah.
Personal coding style.
It's not about finding the right solution.
Exactly.
It's about understanding.
It's about understanding the different tools.
The tools, yeah.
And techniques available.
And choosing the best one.
And choosing the most effective one.
Now, just to add a bit more of a challenge.
Okay.
What if the order string is not unique?
Ooh, interesting.
Meaning characters in order can repeat.
Okay.
How would we modify our approaches?
That's a great question.
Yeah.
It adds another layer of complexity.
How would we even begin to modify these?
Think about how the logic of each approach changes with repeating characters.
Yeah.
We need to ensure that we're not just adding characters based on their presence in order.
Right.
But also based on the number of times they appear.
Right.
We need to preserve that order.
Okay.
So for the frequency counting method,
yeah.
instead of removing a character from the map,
right.
once we've processed it, we need to think about decrementing its count instead of removing it entirely, because it might appear multiple times in order.
Right, right.
So decrementing the count lets us use it as many times as it appears in order, while still keeping the correct sequence.
Okay, so we tweak the frequency counting
right.
to handle the repeating characters.
Exactly.
What about the Radix sort approach?
With repeating characters in order, we can't rely solely on the index for ranking.
Okay.
Because multiple characters might have that same index, so we need to differentiate them.
Okay.
So how can we do that? Any ideas?
Well, I'm thinking, could we use like the original index of the character from S?
Exactly.
And then incorporate that into the ranking calculation.
You got it.
So even if two characters have the same index in order, we can still tell them apart based on their position in X.
Exactly. We're creating like a two-part ranking system.
Okay. Yeah, I like that.
So how do we actually combine these indices to create a unique rank? What if we treated them as strings and then just concatenate them?
Oh, interesting.
So, for example, if a character is at index 2 in order and its original index in S is 5, its combined rank would be 25.
Oh, okay.
So this creates a lexicographic ordering.
Right.
It ensures that characters are sorted first by their position in order and then by their original order in S.
So we're kind of like refining that Radix sort approach.
Yeah, we're refining it.
To handle the repeats.
To accommodate those repeated characters.
Okay.
Got it.
Now I'm curious about the Python solution.
Okay.
With the counter and the list comprehensions.
Yeah.
Would that need any changes?
Surprisingly, the Python solution might require the least amount of modification.
Oh, really?
Yeah, the counter object in Python already preserves the order in which the elements are added.
Right.
So if we create that counter from as, that order of occurrence is automatically captured.
Oh, wow.
And since list comprehensions process elements in the order they appear, our existing solution would maintain the order of duplicates without any extra work.
That's amazing.
It's like Python anticipated this with its built-in tools.
It seems like it.
Yeah.
So we've seen how to adapt all three approaches to handle those repeating characters.
It's fascinating how a small change can lead to some interesting modifications.
It really shows the importance of understanding, like you said.
Understanding those inner workings of data structures and language features.
Adaptability is key.
Absolutely.
It's not always about the perfect solution.
It's not about finding the perfect solution.
Yeah.
It's about understanding those nuances and picking the best one.
This has been a great deep dive.
It has.
Into the custom sort string problem.
Absolutely.
We've explored so many different solutions.
A lot of solutions.
And even uncovered some elegant Python magic.
Some Python magic.
It's a great reminder that even seemingly simple algorithm problems
they can be simple.
Can have rich learning opportunities.
And require us to think critically.
Absolutely. And creatively.
And to all our listeners out there, we encourage you to explore these solutions. Experiment. Try different things out.
Different implementations.
And continue to hone your skills.
Yeah, hone those algorithm design skills.
Until next time on AI.Code.Cast.
Happy coding.
Happy coding.